In this video, we're going to be working an example involving application of the intermediate value theorem. In particular, we're asked to apply the intermediate value theorem to show that x cubed plus x equals minus 1 for some x in the closed interval minus 1 to 0, inclusive of both minus 1 and 0. Hopefully you recall that the intermediate value theorem states that if you have some function f of x that's continuous, so I'll say continuous here. Continuous function f of x, and it's continuous over some closed interval a to b, then you know that it takes on every single value between f of a and f of b. So then it takes on every possible value between f of a and f of b. For example, let's say f of x is continuous over the closed interval a, b, and f of a equals 2 and f of b equals 6. Then you know somewhere between a and b, so we'll say for some c in the closed interval a to b, f of a or f of c equals 5.5, right? Because this function is going to take on every possible value between f of a and f of b, so it's going to take on every possible value between 2 and 6. So there is going to have to be a c such that f of c, a c in the interval a, b, such that f of c is 5.5. So how are we going to use that to show that x cubed plus x equals minus 1 for some x in this interval? Well, first let's see what the function applied to the endpoints of the interval are. Function values applied to the endpoints of the interval, I should say. So f of minus 1, what's f of minus 1? F of minus 1 looks like it'll be minus 1 cubed. So f plus minus 1, right? F of minus 1 is going to be right here. I should say f of x equals x cubed plus x. And we're interested in, so I'll say closed interval a, b equals minus 1, 0. Right? We're looking at this piece right here. This is, we're going to call this f of x. And we know that f of x is continuous because it's a polynomial function. X cubed plus x is a polynomial function. So it's going to be continuous for all real values of x, including those values in this closed interval between -1 and 0. But let's figure out what f of -1 is. Well, it's going to be minus 1 cubed plus -1. That's just going to be -2. Now how about the right and the function evaluated at the right endpoint of this interval? It's going to be f of 0. That's going to be 0 cubed plus 0. That's just 0. But what's the question asking? We want to show that this function equals minus 1 for some point in this interval. So if at one endpoint the function equals minus 2, and if at the other endpoint it equals 0, well, minus 1 is between minus 2 and 0, right? So we'll say f of -1 equals minus 2 is less than minus 1, which is in turn less than f of 0, which equals 0, right? So we know by the intermediate value theorem that there exists some point C or some value, we'll just say some number c such that f of c equals -1. So some value c, some number c in the interval. So I should say the interval -1, 0, such that f of c is -1. And that's exactly what we were asked to show.